honors chemistry. This is the 5 types of radioactive decay. Yay! So why does radiation or decay occur? Because something is happening in the nucleus. When an up quark changes to a down quark, or when a down quark changes to an up quark, it causes the identity of the subatomic particles to change. So it causes a proton to become a neutron or a neutron to become a proton. And when the nucleus experiences any changes, like quark switching or energy being added, strong and weak nuclear force break down and the atom experiences decay. And you might be asking, but Miss Johnson, why though? And the reason why is because, well, when we talked about strong nuclear force, we discussed it only works between protons and neutrons over a small space, and the same thing is true for weak nuclear force. It only works between quarks, which is an even tinier distance. So when a quark changes, the weak nuclear force breaks down because it becomes unbalanced. What? And when weak nuclear force breaks down, it also causes strong nuclear force to break down too. And the reason why is because of distance. When the protons and neutrons change their identity, the distance changes between them too. So if they're too close together or they're too far apart, the strong nuclear force will break down. So there are 5 types of radiation, aka decay, that we learn in this class. And we have to know the notation for the radiation particles, or the radiation notation. That rhymes. So beta particles are very fast-moving electrons. Alpha particles are just heliums with no electrons. Positron is the antiparticle of the electron, and it's positively charged, has no mass, well, almost none. And then there's the gamma ray, which has no mass and no charge. So types of decay, the very first one we learned was alpha decay. And that is when that 1-to-1 ratio becomes too far off. One of the chunks of the nucleus is going to split apart because it's become imbalanced. And one of those little chunks that comes out is going to be an alpha particle. When we talked about beta decay, we said that beta particles are very fast-moving electrons. This radiation is dangerous. It's cancer-causing over time. And beta particles leave the nucleus when a neutron changes to a proton. So in this example, sodium is going through beta decay and it becomes magnesium. It becomes an isotope of magnesium. And over here you can see that we are adding. Now in gamma ray production, this is something, and I know I use uranium-238 all the time, but it's a good one. It happens after alpha decay. Gamma rays are deadly. They're very fast-moving photons, which are also waves of energy. They have a short wavelength and a very high frequency. When we talked about positron emission, positrons are the antiparticles of electrons. They are positively charged. They're the same mass and size of an electron, but the opposite charge. And it comes out of the nucleus when a quark changes and a proton becomes a neutron. So this time we're going to be subtracting. So now sodium is becoming neon. When we talked about annihilation, we discussed how a positron and a beta particle annihilate one another and produce two gamma rays. All right. The last type of decay we talked about was electron capture. And this is what happens when an electron gets sucked into the nucleus. It's an inner orbital electron. And once it gets absorbed into the nucleus, that's going to cause that little quark to change. The proton will become a neutron and a gamma ray is going to be released. So this time we're going to be subtracting one. All right, you guys, if you're kind of wondering what you should be doing, well, I gave you a homework sheet where we could practice writing a whole bunch of reactions that you can look up on Teams. So don't give up. Chemists try. Good night.